Hey guys, how's it going? My name is Nam, and today I'm going to be teaching you guys about definite integration. So let's say we have a very simple problem. So let's say we're finding the integral from 3 to 5 of, say, 5x dx. And so, as you may know from past lessons, when you're integrating, you're basically finding the area under the curve. So with definite integration, we're doing that same concept, but in this time, we're going to be doing it in a certain interval. So say for this case, we have 5x. So the graph will look somewhat like this, like a line going upwards. And in this equation, since you're finding the integral from 3 to 5, it's going to be finding the area from 3 over here to 5 over here. So in this case, we're going to be working out the area under the curve right here. So the way we do this is that first of all, what we have to do is we have to find the antiderivative of the equation in here, which is 5x. So with this, what you're going to be doing is you're going to be doing the opposite of what you do for finding the derivative. So in this case, you're going to be bringing x to the next interval. So in this case, since it's just x, so with x to the first power, you're going to be bringing it to x to the second power. And once you bring it to, and instead of multiplying the number with the front number in the front, you're going to be dividing. So in this case, so you have 5x first. And what you're going to do is you're going to make the x squared, and you're going to divide the 5 by the number 2. So it's just going to be 2 on the bottom like this. And that's how you find your antiderivative. Now, from here, what you're going to have to do is you're going to have to find the area under the curve. So in this case, what you're going to have to do is you're going to have to plug in the numbers 5 and 3. So basically the endpoints. And the reason we do this is so that we can narrow out this area, because if we just plug in 5, we're going to be finding the whole area from 0 to 5. And when we plug in 3, that means that we get rid of this small area right here. So it ensures that we get the entire area right here and nothing more or less. So let's plug it in. So 5 times 5 squared divided by 2. And from there, we're going to subtract, as we said earlier, 5 times 3 squared divided by 2. And what we're going to end up with is, 125 over 2. Subtract from that, we're going to get 5 times 9, which is 45 over 2. And so we're going to end up with the final answer of 80 over 2, which is just 40. So now that we have the basic concept with a very simple question, let's apply this concept to much more complicated questions. So for our next example, we're going to do the integral from 0 to 6 of 4x squared plus 3x plus 2 dx. Now for this question, you're going to use the same process. So with this, you're going to find the antiderivative of this equation. Fairly similar to a derivative equation, you're going to find the antiderivative for each portion of this addition. So let's start off with the first one, which is just 4x squared. So the next interval will be 3, so it'll be x cubed. You have the 4 still there. And remember, you got to divide by the 3, so you have the 3 on the bottom right there. Same thing over here. So the next interval, it's going to be 3x squared. You got to divide that by 2. And then finally, for this last one, since the x is to the 0 power, it'll just be x. So you're just going to end up with 2x. Same thing over here. Same thing as up over here. You're going to plug in 6, and you're going to plug in 0. So we know that when you plug in 0 to here, that's just going to end up with 0. So let's just plug in the 6. So 4 times 6 cubed over 3 plus 3 times 6 squared divided by 2 plus 2 times 6. So we'll solve this out. So that's 12. 3 times 36. 3 times 36, that is 108. So 108 divided by 2, that'll be 54. And then 4 times 6 cubed. So 4 times 6 cubed, that'll give us 864 over 3. That gives us 288. So this cancels out and we just get 288. So let's add these three together. 54 plus 12 plus 288. We end up with the final answer of 354. Now we can use the same concept as we do with these algebraic equations with something like a sine equation. So let's say in this case in the next case, we can have an example of from 0 to pi over 2 of the equation sine x dx, like so. And we're going to be doing the same process as before, except in this case, since we don't have this, we know that since the derivative of sine x is cosine x, or the derivative of cosine x of negative cosine x is sine x, we can tell that the antiderivative of this equation of sine x will be negative cosine x. Same as before, plug in the pi over 2 and the 0. So you have negative cosine pi over 2, and subtract from that negative cosine of 0. We can solve this out. So negative cosine of pi over 2, that'll just be 0. And then you're going to subtract from that negative cosine of 0, which is going to be negative 1. So you're going to end up with your final answer of 1. And that is how you integrate definite integrals. Thanks for watching, guys.